All right, so the first one says find the standard form of the equation of the hyperbola with foci -1, 5, -1, 1, vertices -1, 2, and -1, 4. So if you are keeping track of a reference sheet and you added yesterday, you did the parabolas and the circles and the ellipses, then you can add in hyperbolas. And remember that there are two kinds, right? So hyperbolas. There's horizontal, I'll go in the same order, horizontal and vertical. The difference is the order. So horizontal is x minus h squared over a squared minus y minus k squared over b squared equals 1. And vertical would be y minus k squared over a squared minus x minus h squared over b squared equals 1. For both of these, a comes first. So it would be the positive variable. That is different from ellipse. Also, for both of them, the center is your HK. Again, A is vertex to, sorry, not vertex. Sorry, God bless you. Center to vertex. B is center to covertex, and those are the ones you make the little box for to find the asymptotes. C is center to foci. Another major difference between hyperbolas and ellipses is that c squared equals a squared plus b squared. For hyperbolas, remember it's the opposite sign than your standard equation. This time we call it a transverse axis, which is the same thing as the major axis, that's 2a, and a conjugate axis, which is the same thing as a minor axis, and that's 2b. And then this is the first time asymptotes get brought in. If it's a horizontal hyperbola, then it's y equals k plus and minus b over a, x minus h. And if it's a vertical hyperbola, then it's y equals k plus and minus a over b, x minus h. So again, I mean, depending on what kind of learner you are, if if writing it helps you remember it, then keep rewriting all that stuff out. If you're an audio person, I apologize in advance, but you're going to listen to my voice over and over again saying those things. If you're a visual person, feel free to just stare at it for hours until it sinks in. Anybody still coming down? All right, so with this one, it says find the standard form of the equation of the hyperbola, and it gives you first the foci, -1, 5, and -1, 1. So -1, 5, and -1, 1. Those are the foci. What does that tell you about your hyperbola already?
It's vertical.
Good, it's vertical, which means what variable comes first? Y squared minus x squared is going to be my formula, obviously with my k and my h, but at least I know that part. That also tells me that my asymptotes, which I didn't ask for, but if it had asked for asymptotes, would be the a over b ones. What else do we know from the foci? Or what can we find? You can find c by finding first what? The center. So center is the midpoint between these, which is -2, 3. That's my center. Now I already know all the numerators. So y minus 3 squared minus x minus a -2 becomes plus 2 squared equals 1.
Would it be -1?
Oh, right. Sorry. Struggling to count this morning. -1, 3. So this is 1. Okay. Then your c is the distance from that center to the foci in either direction. So I know c is 2. Second piece of information given is that the vertices are at -1, 2 and -1, 4. So it's consistent with my vertical hyperbola, and the distance from the center to the vertex is your a. So a is 1. Because c squared equals a squared plus b squared, 2 squared would equal 1 squared plus b squared, 4 equals 1 plus b squared, and b squared equals 3. So now I have my a squared. A was 1, so a squared would also be 1. And I have my b squared, which is 3. You do not need the 1 underneath the y. If you don't have it there, it's still right. If you leave it there, it's also right. Like, I'm not going to mark it wrong if you leave it there. But that's all we needed, just the equation. Questions on that one? All right, 2 said put the equation into standard form, identify the center, the vertices, the foci, and the asymptote. So I've got to complete the square on this one. I'm going to group together the 9x squared and the negative 18x. Then I'm going to group together the negative 4y squared plus 16y. And then I'm going to bump the 43 to the other side. I'm going to take out the 9, and I get x squared minus 2x. Leave that space. I'm going to take out a negative 4y squared, which changes this sign. Negative 4y equals 43. Complete the square for each. So 2 divided by 2 is 1. 1 squared is 1. Add the 1 here. Normally I'd add the 1, but I got to multiply by 9 first. So I'm adding 9. Repeat the process for the y. 4 divided by 2 is 2. 2 squared is 4. Add the 4. Normally I'd add the 4, but I have to multiply by a negative 4 this time, which means I'm subtracting 16. So I would factor out these 9, square root, take the sign from the middle, put it in the parentheses and square it. Minus 4, square root, take the sign from the middle, put it in the parentheses and square it. And then this is 52. 52 minus 16 is 36. To get it into standard form, I have to last step, divide everything by 36 because it has to equal 1. And I get x minus 1 squared over 4 minus y minus 2 squared over 9 equals 1. Now tell me what you know about this hyperbola. Okay, go ahead. Center is 1, 2. What kind of hyperbola is it? Horizontal. All right, what else can you tell me? Well, before you get there, like what's your a squared and your b squared? What's a squared? Good. Good. Okay, now I can graph it from that stuff. So 1, 2 is my center. We said it's horizontal, so I'm going right and left the A. So right 2, left 2, and those are the vertices. Negative 1, 2, and 3, 2. I go up and down B, which is 3. And those are the co-vertices. 1, 5, and 1, negative 1. And then I would make the little box. Find the corners of that box. And draw the asymptotes through the opposite corners. We said it's horizontal, so I point my branches right and left, making them as wide as possible without touching those asymptotes. It also wants you to find the foci. So to get C, I know C squared equals A squared plus B squared. C squared would equal 13. C would equal the square root of 13. And to that, we would add that to the x coordinate of your center. So foci is 1 plus and minus square root 13, 2. And the asymptotes, because it's horizontal, which means it's the B over A equation, I would get y equals K, which is, my center, which is 2 plus and minus A over B, so 2 over 3, or no, sorry, it's B over A, 3 over 2, x minus 1. And then your asymptotes can literally stay just like that. If you wanted to check them against what you drew from the box, you would have to distribute your 3 halves, combine your like terms, put it into slope-intercept form, and then graph it. Or go to your center and use your slope, which is the 3 over 2, and see if it completes your asymptote.
When you say identify the vertices, do you mean both the...
It will say it on the test. I know sometimes it's not included, but it will say it on the test. You'll actually get a line for each of those things that I want. All right, the last one was the easy one, right? So we have to identify A, and that is 9, C, and that is negative 4. A is what's in front of the x squared, C is what's in front of the y squared. They are not the same. That's the first check. That would make it a circle. Their product would be negative, which makes this what? Hyperbola, good. Every year, like I think that's the easiest question on the test. And every year somebody messes it by not remembering the A and C combinations. Like, that is a silly thing to do. Do not let that be you, okay? Questions on hyperbolas before we get into rotation of conics? Okay, take a deep breath, folks. If you are one of those people that like normally allows yourself to get distracted, you come in and out and you think you can be okay, don't do that today. If you have something open on your iPad that is not the notes, don't do it, okay? This is one of those processes that is long and tedious, but it is the same steps on repeat. So once you learn the steps, it is not that it is hard, it is just long and tedious, okay? But it is something we have not done before, so it is important that I have your full attention today, and I would prefer not to have to micromanage you and lock you in. So please just be mature enough and smart enough to know that you need to pay attention. So this is part 2, which is rotations. So the rotation, to eliminate an xy term, because that's what causes a rotation in your equation, you're now going to see an xy term. To eliminate that xy term, we use a procedure called the rotation of the axis. The objective is to rotate and the x and y axis, rotate the x and y axes until they are parallel to the axis of the conic. So you are actually going to take your normal xy coordinate axes, and you are going to rotate them a specific angle. And then you are going to graph your conic on that new rotation. So like, this is one of those opportunities, I think it's easier to do on paper. You physically take your paper and you will turn it. And you will graph on that new one. So if it was an ellipse on this, it would be turned at an angle. Like maybe it's a vertical ellipse where it's taller than it is wide. It would look like that. If it was a hyperbola and it was vertical, it would look something like that. It would be on your new axis. So there are 2 major parts to it. The first is finding out what angle you are rotating it to, and then the second is finding the standard form of that equation. We use x prime and y prime to show the rotated axis. So when you see x prime and y prime, it means the axis has been rotated. It is not your normal x and y axis, okay? Those little apostrophes are primes in math. So first, and this is not like a question on your test, but the first thing we're going to do is take a coordinate point and rotate it. So this says the x, y, or x prime, y prime coordinate system has been rotated theta degrees from the x, y coordinate system. The coordinates of the point are given. Find the coordinates of the point in the rotated coordinate system. So it's telling you to take your actual x, y and rotate it 90 degrees and then plot this new coordinate. So if I took my original x, y axis, all right, so this would be your x, and this would be your y. And then you're going to rotate it 90 degrees counterclockwise, the way we normally rotate it. So I go to like wherever the 90 degrees mark, which is up here, and I'm going to make that the new x. So I physically take the slide, and I rotate it 90 degrees. And I put x, or y prime is now at the top, and x prime is now at the right. So y prime is at the top. I rotated my slide around. If you're using, obviously, you're using your iPad for notability or whatever, you just need to take your iPad and literally rotate it around, okay? On your test, and again, you won't do it for the coordinate point, but you're going to do this for the actual conic. I would literally take the paper and I would turn it sideways, or whatever the degree is. If I was to graph it, let's say it was 30 degrees, I would turn it left. I would go to 30 degrees, I would draw the line at 30 degrees, and then I make that my north. I make that the top, and then I would draw the axis from there. I'll show you that in a second. So now we're pretending this is our new coordinate grid, and we want to graph 4, 0. So I'd start at 0, I go to the right, 1, 2, 3, 4, and I plot a point because that would be 4, 0. So it is 4, 0 on my new rotated graph. Now, in order to find the actual coordinate that would have been on the original graph, I want to rotate it back and look at your original graph. What would be the coordinate point? 0, 4. So the ones that rotate like 90 degrees or 180 degrees or something like that, those are going to be exact answers at the end because those will end up being on an axis. But if I had said take theta and rotate it, 30 degrees, my xy, my original xy, I would eyeball where 30 normally is, which is like about there, probably a little bit smaller, but about there. Then I would rotate it so that that was at the top of my graph. I would then extend that axis and draw a perpendicular line. This would be my y prime and this would be my x prime. So you're finding the location of the angle in which you are going to rotate to, and then you turn it so that that angle is at the top and extend it to make it your axis. Okay? Yeah.
Isn't that clockwise rotation?
So the first time you graph it, you're graphing it counterclockwise. Like we go counterclockwise to find 30 degrees. But then when we rotate it, we have to rotate it clockwise. Yeah. So then if I was to graph something like this, like if it said 3, 0, 1, 2, 3, I'd go here, 3, 0. Now I rotate it back. And now my coordinate point is in the 4th quadrant, okay? Which again is not an exact point. You wouldn't be able to find the exact point there. It would be an approximation. So there's like one question on the coordinate point, but the beef of this section comes from what's about to happen, which is the rotation of the actual conic. It is important to understand how to rotate it, how to find your new y prime and x prime, and then how to graph on that.
I'm confused. Can you repeat if we graph it counterclockwise?
So when you start it to find your new axis, you use the angles going in a counterclockwise motion, just like the unit circle. So if I said to rotate theta to 60 degrees, right? There's my normal XY axis. 60 degrees is up here. Now I need to make 60 degrees go where 90 degrees goes. So I rotate it, technically I rotate it that way. Does that make sense?
Yeah.
So now I'd rotate this, oh I can't, there. So that I can, work with me. So that 60 is now the top. I would make this my y prime and my x prime. So locate your angle. Turn it so that angle's at the top. Graph whatever you need to graph, but then obviously when I'm looking at a paper, you're actually turning this in, it would be rotated back. Yeah. Adam, you had a question?
So, yeah, I'm just trying to make sure.
Here's the fun stuff. Say that very sarcastically, okay? So the rotation of a conic occurs by actually taking your conic, your axis, finding the new y prime, x prime, and then graphing your ellipse, hyperbola, circle, or what did I miss? Parabola on that rotated axis. So you could totally ignore that middle thing, like you don't need it, to be honest. It's just telling you that you're doing this with the x, y, and what it would end up resulting by. What's important is this, and we talked about this yesterday. From that equation, so your equations are now going to have x, y's on them. That's what makes them something you have to rotate. The a is what's in front of the x squared, just like we did with classifying. The c is what's in front of the y squared. And the b is the third thing we're going to involve, and that's what's in front of the x, y. So you're going to identify your a, your b, your c. Then the first thing you're going to do is figure out what angle are we rotating this at, and that's what this formula is for. So the cotangent of 2 theta is a minus c over b. So whatever a is you plug in, subtract c from it, put it over b, simplify it. What you get from that has to be a unit circle angle. It will be in radians, okay? Well, no, the angle won't be in radians. What you get from that has to be the result of a unit circle's angle. But this is cotangent. So before I even do the 2 theta, I flip it and make it tangent of 2 theta. And then that answer is either going to be 0, 1, root 3 over 3, or undefined. Because those are the only answers for tangent on your unit circle. Then from there, you'll figure out what angle it is. You'll set it equal to 2 theta. You'll solve for theta by multiplying by half. And then that's the rotated angle. Okay? So there is a limited amount of answers you can get from this without a calculator, which is what we're going to do. Yeah. You will not have a calculator. Nope. And then you're going to take your equation, you're going to replace x with this whole thing, x prime times the cosine of theta minus y prime times the sine of theta. And you're going to replace y with x prime times the sine of theta plus y prime times the cosine of theta. I am going to give you those 2 things on this question. Okay, so these are not the formulas you need to remember. I'm going to give you these formulas. You just got to figure out how to use them. Okay, so this is not on your notes. If you'll put either add a slide in or find a way to add it to the slide previous, it doesn't matter how. But these are some reviewed skills that are going to help us in the next couple of questions. The first is special products. So there are 2 types of special products that you're going to see when we start to expand these, and they are the difference of 2 squares product, so opposites, and the square of a binomial. And then we'll review unit circle and the tangents on the unit circle because you're going to need that as well. So for the special products, if I have an x minus y and an x plus y, what's the result of that? X squared minus y squared. So if it was x minus 3, x plus 3, I'd end up plus 3, x minus 3. I'd end up with x squared minus 9. So we do a squared minus b squared there. That's the shortcut, okay? You're going to want to use as many shortcuts as you can in this stuff. That's one of them. So if they are exact opposites, they have to be the same terms. One gets a plus, one gets a minus. And you want to FOIL them out. You could FOIL them out, but if you remember this special product, it will help you in your time. And that is just x squared minus y squared. If you have, let's start with it being positive, and then we'll talk about if it's negative. If I had a square of a binomial, so x plus y squared, I could put it next to it. I could FOIL it out. I'd get x squared plus xy plus xy plus y squared, and x squared plus 2xy plus y squared. I could FOIL it out. Or the shortcut is square the first, square the last, and then double the product. This will always be a plus. This is going to take the sign of that middle term. So if it's a product, I use it to actually multiply the signs. So if I had, let's say I had x minus 3 squared. Without expanding and FOILing that, the first term would be x squared. The last term would be a positive 9, because if I square negative 3, it's positive 9. Multiply these together, negative 3x, and then double it, and I get negative 6x. And that's the product of those two. So if you have a binomial squared, you square the first, you square the last, you double the product for the middle two, okay? Those are some skills, again, that are going to help you with time on these questions. When in doubt, you have to FOIL it out. That's all. The other thing is unit circle. So you're definitely going to need your unit circle, but you can survive off of first quadrant for these questions. So first quadrant, obviously, is 0. We will do these in radians. So 0, pi over 6, pi over 4, pi over 3, pi over 2. The coordinate points there you want to know. At 0, it's 1, 0. At pi over 6, it's root 3 over 2 and 1/2. At pi over 4, it's root 2 over 2 and root 2 over 2. At pi over 3, 1/2, root 3 over 2. And at pi over 2, 0, 1. Then you also want to know the tangents at these. So at 0, my tangent is 0. At pi over 6, it's root 3 over 3. At pi over 4, it's 1. At pi over 3, it's root 3. And at pi over 2, it's undefined. Those you need for the rotation. So if these are not something you already have like stored in your memory somewhere, you need to do so. Anybody still copying that down? Okay. All right, here we go. So it says rotate the axis to eliminate the xy term in the equation of xy minus 1 equals 0. Then write the equation in standard form and sketch its graph. So again, these two formulas I will give you. I'll also give you the cotangent one. Cotangent 2 theta equals a minus c over b. And that's the one we're going to do first. So we're going to identify a. Do you see an x squared term? If this is my equation. Is there an x squared term? No. So what is a? 0. B is what's in front of the xy. What's b? 1. And c is what's in front of the y squared. What would that be? 0. So cotangent of 2 theta equals 0 minus 0 over 1, or 0 over 1, which is what? 0. So we're looking initially for a cotangent being 0. But we didn't memorize the cotangent points. We memorized the tangent points. So I'm going to flip this and make it the tan of 2 theta equals, what's the reciprocal of 0? Or undefined. Good. So what angle had a tangent that is undefined? Pi over 2. So 2 theta equals pi over 2. And then to get theta alone, I'm going to do what? multiply by a half or divide by 2, and I get theta equals pi over 4. That's the first part. And a very important part, because if you get that wrong, you get the whole rest of it wrong. All right, now I have to plug in for every x, this, and for every y, this. So this one's not so bad because I only have one of each. It's going to get worse. So I would get x, and I would make it x prime. Cosine, I now know theta is pi over 4, so I'm going to plug it in its place. Minus y prime sine pi over 4. That's the x. And then I replace the y, x prime sine theta, which is pi over 4, plus y prime cosine theta, which is pi over 4, minus 1 equals 0. So don't forget about the rest of your equation. With me so far? The order and the plus and minus sign. Yeah. Yep.
Why exactly are you multiplying them together?
Because the original equation is x times y minus 1. So whatever was there, we just replace. So now I need to know both sine and cosine at pi over 4. What's the coordinate point at pi over 4? What's the coordinate point? Square root 2 over 2 and square root 2 over 2. So this one's the easy one because they all get the same thing. So I'm going to do 2 things in this step. Well, I'm actually going to do 3 things in this step. I'm going to replace all of these with root 2 over 2, root 2 over 2, root 2 over 2, and root 2 over 2. But I'm also going to switch these. I'm going to put the value before the x prime and the value before the y prime just because it's easier to actually then go multiply. The other thing I'm going to do is, thank you, I'm going to leave out the primes for now just because I'm lazy and I don't want to have to write them every time. But, and you can do the same. But at the end, when you go to give me the equation that's in standard form, you have to make sure you put your primes back in because we changed this equation. It's no longer the same, okay? So I'm going to rewrite this as root 2 over 2x minus root 2 over 2y times root 2 over 2x plus root 2 over 2y. Minus 1 equals 0. Again, don't forget about the rest of it. Now, what do you notice about those two sums and differences? They are opposites, so this is going to result in the difference of 2 squares. If you don't catch it, you're going to FOIL it out. You will eventually catch it. But if you catch it, you can save yourself sometimes, and this will only happen on a pi over 4. This doesn't happen all the time, okay? But it happens on a pi over 4. If you do catch it, it's going to save you the time. So I would square this term. So this would be root 2 over 2 squared x squared minus, I'm going to square this term, root 2 over 2 squared y squared minus 1 equals 0. So the square of the square root of 2 is what? The square of the square root of 2 is 2. The square of 2 is 4. X squared minus the square of the square root of 2 is 2 over 2 squared, which is 4, y squared, minus 1 equals 0. This becomes 1/2 and 1/2. So I get 1/2 x squared minus 1/2 y squared minus 1 equals 0. So we're slowly making our way into the standard form of a conic. What conic do you see starting to happen here? It's a hyperbola. Why do you know it's a hyperbola? Because of the minus. If it was a plus, it would have been a circle because they are the same, but it is not. So I'm going to start to write it in the way that a hyperbola is written. X squared over 2 minus y squared over 2, and I'm going to bump the 1 to the other side. And then what did we say has to be on that last step? Primes have to come back in. So this is x prime squared over 2 minus y prime squared over 2 equals 1. We said this is a hyperbola. Tell me what you know about this hyperbola.
Center is at 0, 0.
Center is 0, 0. Vertical or horizontal?
Horizontal.
Horizontal. A squared is 2. So A would be square root of 2, and we're going to have to graph this. So I'm going to say that's like a 1.2 approximately. B squared is also 2. B would be square root of 2, which again is like a 1.2. I don't need the asymptotes. It's not asking for the equation, and I can use the box. So I don't need the asymptotes. I already have everything I need to graph it. But I have to rotate the axis. So I'm going to start with my regular XY axis. This is my Y, this is my X. What angle are we rotating this at? 45 degrees. So 45 degrees is here. It dead in between the X and Y. This would be pi over 4 or 45 degrees. So now I have to physically rotate this. Let's see if I can take a picture of it and then rotate it. So I'm going to rotate it again. If you're using your iPad, you're going to use paper. You're going to lay it flat and you're going to physically rotate it so pi over 4 is at the top. And then I'm going to extend out that graph so that that is my XY axis. So this is Y prime and this is X prime. We said the hyperbola has a center at 0, 0, so I'm going to plot my point at 0, 0. We said the A is it's horizontal, so the A is right and left. 1.2. I'm going to eyeball this because you won't have an axis drawn, so it doesn't have to be perfect, okay? But whatever spacing you use, you want to be consistent on. 1.2 means that these two are my vertices, and these two are my co-vertices. I make the box. I draw my asymptotes through the corner, and because it's 45, it actually should overlap on your y-axis, so that makes sense. And I draw my hyperbolas right and left because it's horizontal as wide as possible. Oops, I didn't go on that point. Without touching your asymptotes. So then when this is turned back into the test, this is how I should see it. It should be a hyperbola that is rotated pi over 4. This is much more on level with what your test question is going to look like. So it's the same exact process. Ignore this. This is your equation. Same set of instructions. Rotate the axis to eliminate the xy term in the equation. Write the equation in standard form and sketch its graph. Okay. So step 1 is what? Cry. Identify A, B, and C, right? So A is 13. C, 7. B, 6 root 3. Then come over here. So 13 minus 7 over 6 root 3 becomes 6 over 6 root 3, which becomes 1 over root 3. Now, normally I would say rationalize that, but we're about to flip it, so don't. Because the equation says cotangent, but we know our tangent, so we're going to say tangent of 2 theta equals the reciprocal of that, which is root 3 over 1 or root 3. But you do you, boo. All right, so now what angle has a tangent of root 3? Pi over 3. So 2 theta equals pi over 3, and then I divide by 2 or multiply by 1/2, and I get pi over 6. So that tells me, one, all the thetas in my equation are going to be pi over 6, but it also tells me at the end that that's where I'm going to rotate my axis to, okay? So a really important piece of information, and you want to do that carefully, because if you do that wrong, like you're wrong from here on out on multiple things. The tangent of root 3, So this was tan. The tangent of root 3, the tangent of an angle that is root 3, that angle results as pi over 3. So pi over 3 is the angle that has a tangent of root 3. All right, now the fun comes. You're going to want to give yourself lots of space, maybe shrink. So those of you that write like huge and take up 17 pieces of paper for homework, whew, that's going to be fun. So the x becomes x prime cosine theta plus y prime, not plus, minus y prime sine theta. And then the y, x prime sine theta plus y prime cosine theta. So the order changes and the signs changes. No, I'm going to give you that. So everywhere there's an x, I'm writing that whole thing out. So 13 x prime cosine, and save us a step. We already know theta, put it in. Pi over 6 minus y prime sine pi over 6 squared plus 6 root 3 x, which is x prime cosine pi over 6 minus y prime sine over pi over 6 times y, which is x prime sine pi over 6 plus y prime cosine pi over 6 plus 7. Let's see if I can move this. Y, which is x prime sine pi over 6 plus y prime cosine pi over 6 minus 16 equals 0. All right, so those special products are happening. Yeah. Oh, squared, thank you. There's two things I want to do now. I want to replace the values of cosine, right? I'm going to drop the primes. I'm going to bring them back, and I'm going to put the value on the front of the variable. Those 3 things I do in that same step. So at pi over 6, what's your coordinate point? Square root 3 over 2 and 1/2. So my cosine is the square root 3, and the sine's the 1/2. So I'm going to get 13 square root 3 over 2x minus 1/2 y squared plus 6 root 3 over 2 x minus 1/2 y times 1/2 x plus root 3 over 2 y plus 7 times 1/2 x plus root 3 over 2 y squared minus 16 equals 0. At any point, you can move the 16 to the other side. So sometimes I do it then. You could wait and do it later. It doesn't matter when, but just don't forget about that 16. With me so far? So the shortcut on the squareds, like on this one, I'm going to do over here on this side. If it's squared, well, I won't even do it on the side. I'll just do it there. I'm going to keep the 13 in the front. I square the first term, so the square root of 3 squared is 3. 2 squared is 4. X squared. The last one is square of 1 over square of 2, y squared. And the middle is the doubled the product. So 2 times square root 3. And 2 times 2 is 4, x, y. This sign sticks with the middle, but the last sign's positive. Now you can simplify that, but I'm actually going to keep it as over 4, and I'll show you why in a second. But obviously 2 goes into 4. I could have simplified that, but don't, because I'll show you a way to get rid of all those fractions in just a minute. Okay, now I go to the second one. Now they almost look like they're completely square, like they're opposites, but they are not. They have to be in the same order, and they are not in the same order, which means I have to FOIL this out. So that I'm going to do off to the side. So root 3 over 2 x minus 1/2 y times 1/2 x plus root 3 over 2 y. And I'm going to FOIL this out. So root 3 times 1 is root 3. 2 times 2 is 4x squared. Plus outer, root 3 times root 3 is 3. 2 times 2 is 4xy. Minus 1/4 xy. Minus root 3 over 4y squared. Combine your like terms. I get root 3 over 4x squared plus 2/4 xy minus root 3 over 4y squared. And again, I know you can simplify that middle term, but we're going to keep it over 4 for a reason. So this becomes plus 6 root 3 times root 3 over 4x squared plus 2/4 xy minus root 3 over 4y squared. And then I get to use the special product on the last one because it's squared. So the plus 7 stays. I square the first term, which would be 1/4 x squared. I square the last term, which would be positive 3/4 y squared. And I double the product. So 2 times root 2, this time is positive, 2 root 3 over 2 times 2, which is 4xy. And I'm going to bump the 16 to the other side. You could keep it there, move it later. It doesn't matter when you move it, just don't lose it. With me so far? Okay, so all of those fractions have what as a denominator? 4. We kept it intentionally so that they are all the same because if I multiply everything by 4, I can get rid of all those denominators. The most important thing on this step and the thing that gets messed up the most is forgetting to also multiply it by the 16. So the 4 into the first one literally cancels all the denominators and it doesn't affect the 13. In the second one, it cancels into all the denominators and doesn't affect the 6 root 3. In the third one, it cancels into all the denominators and doesn't affect the 7. But you have to multiply it by the 16. And that is what most people mess up.
Why does it not affect the...
Because technically what you would have done is multiplied 4 times 13, and then that 4 would have gone into all of them.
Oh, okay.
So it would have canceled it back out anyways.
Okay.
Yep. So now I've got, and I'm going to distribute in 13 to all of these. So 13 times 3 is 39x squared. 13 times negative 2 root 3 is negative 26 root 3 xy. 13 times 1 y squared is positive 13y squared. Then I'm going to distribute 6 root 3 in. 6 root 3 times root 3 ends up being 6 times 3, or 18x squared. 6 root 3 times 2 is 12 root 3 xy. 6 root 3 times negative root 3y squared becomes 6 times negative 3, negative 18y squared. Then I go to the last one and I distribute the 7. 7 times 1x squared is 7x squared. 7 times 2 root 3 is 14 root 3 xy. 7 times 3 is 21y squared. Equals 64, because that's 16 times 4. All right, so this next step, I start with the xy's. The whole goal is to eliminate the xy. So if when you combine your like terms, xy does not cancel out, you did something wrong. So I would go with all my xy's, negative 26 root 3 plus 12 root 3, and that gives me negative 14 root 3, plus 14 root 3, and it cancels out. So I know I did that part at least correct. Then I'm going to combine together all my x squareds. So 39, 18, and 7. 4. 64x squared. Let me just finish this one step. Combine together all your y's. 13 minus 18, negative 5, plus 21, 16 equals 64. Then I would divide everything by 64 and bring back my primes. So I'd get x prime squared over 1 plus y prime squared over 4 equals 1.